Amazing. Thank you all. I'm so excited to be here today to talk about building and deploying remote MCP servers. But the nice thing about the session is that we're not just going to talk about it. We're actually going to deploy an MCP server together. And yes, somebody said that it stands for Make Cool Pancakes. That's definitely what it is. But now, in case anybody's unfamiliar with MCP, MCP stands for the Model Context Protocol. So I'm pretty sure that most people that are watching this right now have used an AI tool like ChatGPT, Claude, Cursor, maybe to help you draft an email or revise a blog post or even write up some code to help you build an application. I think at this point, we all know that these AI tools are incredibly knowledgeable and powerful, and they can help boost your productivity. But up until very recently, they have been missing one very important component. And what that is that up until MCP came about, you could ask an AI agent to help you something, and it was really good at telling you how to do it, but it couldn't quite complete the task for you. And that's what MCP changes. So let's go through an example. Let's say you are a new business owner and you just set up your storefront and you need to figure out how to create a PayPal invoice to charge somebody for socks. And you've never used PayPal before, and you turn to maybe Claude, as a lot of users are doing today when they need some information, and you ask it, hey, can you help me with this task? And so before MCP, it would give you the full list of instructions, which is helpful on its own because now you know exactly what you need to do, but it is still up to you as the user to go through and complete each one of these tasks. Now, let's imagine a different world where, let's say, Claude or whatever AI agent you are using is directly integrated with your PayPal account. Now, when you ask it to help you create this invoice, it doesn't give you instructions, but it just does the thing that you asked it to do. And the result that it returns is the actual invoice. And you can probably see how across these two examples, one would have maybe taken you, some number of minutes, maybe hours, but the second one just got you to your result immediately. And so this is exactly what MCP enables. It enables AI agents to interact with services directly, which enables this whole new class of AI-powered integrations and interactions. And so this was just a very small demo of what it looks like to connect an AI agent to a service like PayPal over MCP, but you can really create the same kind of integration for any service that's out there. I've seen MCP servers out there that allow you to turn the lights off in your room by messaging the AI agent. I've seen some that can help you build a whole 3D model by just describing what you want it to look like. So lots of new capabilities. And MCP has been all of the hype lately. I know that I see it on my Twitter timeline all the time, but it's for really good reason. Like I said, MCP unlocks this next generation of AI that allows users to connect the knowledge and the power of their favorite LLMs, which are being improved every single day, with the everyday tools that they use so that they can do even more with them. And so it started with Anthropic developing the standard, but it's actually an open protocol, which means that anybody can contribute to it. That's been one of the reasons why it's been growing and evolving so quickly. It's actually been amazing to watch the community contribute to the protocol itself. And now you have companies like Google, Microsoft, and OpenAI all supporting it. And as we're watching developers build these AI agents, I think MCP is one functionality that's being automatically built into all of them. And just at a high level architecture, in case you're not familiar with it, MCP connects two main parties. You have your MCP client, which is your AI agent. So this can be Claude, this can be ChatGPT, this can be an agent that you build. And then there's the MCP server, which is holds the service that you want to use and exposes different tool calls that essentially map to different operations that you can complete on the service. So if I ask my AI agent something like, hey, can you post an update in a Slack channel? What is going to happen is that the AI agent is going to interpret the request in natural language. It's going to figure out what needs to be done. It's going to determine what tools it needs to call in order to complete the task. And then it is going to use MCP as the standardized protocol to communicate with these different tools that are hosted by the MCP server in order to complete the request. And MCP is a fairly new standard. It came out in November of last year. And when it first launched, it was only available locally, which meant that it, one, was specific to your own device. You had to install these MCP servers on your laptop in order to be able to use them. You don't really feel the pain of that until you get a new laptop and you log into your AI agent, whatever it may be, and all of a sudden, all of your MCP configuration and all your MCP servers, all of them are wiped. Because it is running locally, in order to have some kind of form of authentication, authorization, you could add an API token or just any auth token into a config file. But very quickly, you see how this is very much catered towards developers and not your everyday users. And this was good for it to initially come out. It needed to be this way for it to evolve. It got this in developers' hands, which, like I said, have helped contribute to growing the protocol. But for this technology to be used by anyone, people like my mom that are not technologically savvy, it needs to act like an online service. It needs to feel like a familiar experience where ideally you can log into your AI agent. It's not specific to your device at all. I can log into it from my phone. I can log into it from my laptop, and I can access these MCP servers by just typing in the URL of the service that I want to integrate with. And ideally, once I type in the URL, it can take me to the login page. I can log in. I can grant permission to the AI agent to be able to interact with the service. And from that point on, ideally, whatever MCP servers I may want to add to my agent, those can persist so that if I start something on my laptop and then later on I want to continue that task on another device, I can continue to do that. I don't have to go and reinstall everything from square one. And remote MCP adoption is quickly growing. Actually, just a month ago on May 1st, Anthropic launched the first big remote MCP client. It's now available in Claude.ai. And so what that meant was that Claude users no longer had to use Claude Desktop or manage a config file, install anything in order to use an MCP server. And then in case you're unfamiliar with Cloudflare, we have a large network. We help keep websites, applications online. And a part of that is that we have built out a developer platform where you can build these different applications. And so what we have been working on is making a toolkit. It's part of our Agents SDK that makes it super easy to build and deploy these remote MCP servers. And so don't want to brag, but I'll take the moment. But because it's so easy, all the companies that you see on this page have already built their remote MCP servers on Cloudflare. And just to speak to how quickly everything is evolving and changing, just about a month and a half ago, before this launched, I was giving a presentation and I was talking about this world that we're moving to from local to remote. And it still felt a bit like a dream, like, is it happening? But actually, now it's a month and a half later and you already have remote MCP support within Cursor, VS Code, ChatGPT. And every day we're seeing more and more remote MCP servers being built and these new interactions being unlocked. But instead of me telling you about it, why don't we deploy an MCP server together? So if you want to build an MCP server, and this can be maybe for your company, or maybe this is for your own personal project. You have some functionality that you want to bring into your favorite AI interface. Easiest place to start is the Cloudflare documentation. We've gotten lucky where there's good SEO on this page. So if you don't remember this link, then you can just type in build a remote MCP server and it's going to come up. But you can go here and of course you can read all about it. But what we've done is we've added these deploy to Cloudflare buttons that allow you to deploy an MCP server in one click. And so what this is going to do is it's going to take this example MCP server that is on our GitHub repo, and it is going to automatically deploy it into my Cloudflare account. So it's going to ask me which account I want to deploy this to. It's already connected to my GitHub. And here, all I have to do is add the project name. I've deployed this example a countless number of times, so need to give it a different name every time. And now I'm going to click create and deploy. And what it is going to do now is it's going to take the example on the GitHub repo, it's going to build it, and it's going to deploy it to our global network. And one of the automatic benefits that you get from building your MCP servers on Cloudflare is that we automatically deploy them globally to the whole network. You don't have to choose a region. And so this way, it's always going to be closer to not just the end user, but also so like that, it is done. So now we have this MCP server, and to use it, I'm going to go to this AI Playground. It's a remote MCP client that we built. It is available for anybody to use. You don't have to log in or anything. And here you can type in the URL. So, I got a little far too ahead. Let me clear the authentication. But today, and I'll talk about this in a second, MCP runs on two endpoints. There's -SSE, which was the initial transport method, and there's -MCP, which is the newer one. The MCP servers that you deploy automatically support both, but you can see that it is now connected, and there are these two tools that are available. So one is to add numbers. Can you add 2 and 3? And so now we will see that it is going to make the tool call and it is successful. And the other one is to calculate it. And if you're wondering, what does this actually look like? The code that you as a developer would have to write is essentially just this. All you have to do is define the actual tools that you want to add. So in this case, I want to add 2 different numbers and it's going to return this, but it's just a bit of TypeScript that's needed to get this set up. So let me get back to the slides. So now if anybody asks if you've deployed an MCP server, you can say that you have, but I would prefer that you all go and click on this button yourselves so that you can all have your own personalized MCP server. And so what we just deployed, it's completely remote, which means it's running on the internet. It's accessible from any device, any agent. And in general, remote MCP servers have 3 major components to them. There's the transport layer, there is authentication, and there's authorization. This example did not have auth as a part of it. This is just to make it very easy for you to deploy. And of course, you can add the auth component on top of it later on. Let's talk about these. So transport defines how the client and the server can communicate with one another to send messages. And the MCP spec defines 3 standard transport mechanisms. So there's STDIO, which is for local connections. This is what was used before remote MCP. And I don't think that this is completely going away. I still think that it's really helpful to have MCP servers that are local, because sometimes you do want them to grab information from your specific device. So helpful in those cases. But then for remote MCP, there's 2 transport methods. The first one that was developed was server sent events. Server sent events uses a single connection, but two endpoints for the communication. So one endpoint to establish a server sent event connection that the client keeps open for receiving responses and updates from the server. And then another endpoint -SSE-messages, which is where the client sends requests for tool calls. And so this works, but it's kind of like having a conversation with two different phones, one which is for listening and one which is for speaking. So this definitely can add complexity to the setup and can make it harder to scale. Not only that, but it also requires the connections to be kept open for long periods of time. And this is because SSE operates as a persistent one-way channel where the servers push updates to the clients. And so that means that if the connection closes prematurely, maybe if there's a network issue, then clients are going to miss responses or updates that are sent from the MCP server during long-running operations. And so to help with this, a new transport method was developed for remote MCP. It is called streamable HTTP, and it addresses all of these challenges by enabling communication to happen through a single endpoint. So now all the interactions go through just one endpoint, eliminating the need to manage these two separate ones for the requests and the responses. This instantly reduces the complexity. It also enables bidirectional communication because now the servers can send notifications and requests back to the client on the same connection, which means that the server can now prompt for additional information if it needs that from the client, or maybe give real-time updates during long-running tasks. And it also allows for automatic connection upgrades. So connections can start as standard HTTP requests, but be dynamically upgraded to server sent events to stream responses during long-running tasks. So now when an AI agent wants to call a tool on a remote MCP server, it can just do it through one post request to one endpoint. And then depending on the tool call, it can either respond immediately or it can decide to upgrade the connection to SSE to stream the response as it becomes available, and do this all over the same request. And streamable HTTP, same as remote MCP, is getting adopted by more and more clients. I know Cursor, VS Code now support it. And yeah, that's going to be the way forward. But one of the big benefits of using Cloudflare, and we just saw this, even though it was invisible, in the example that we just deployed, is that Cloudflare handles all of this on your behalf. So you actually don't have to worry about implementing anything transport specific. The boilerplate that we deployed earlier automatically supports both SSE, so you can be backwards compatible, but also streamable HTTP so that you are future-proof and ready for all of these MCP clients as they upgrade to the new transport method. And right now, the implementation of streamable HTTP that we have has feature parity with SSE. But one of the things that we are working on is supporting new features that are going to be coming in with streamable HTTP. So for example, resumability, which helps with long-running operations. That means that if a connection drops during a long-running task, the client can resume exactly where it left off without missing any of the responses. And so that eliminates the need for keeping the connections open for a long time. This is especially ideal for any agents that might be running for hours, if they're processing large data sets or performing some complex analysis, or maybe executing a multi-step workflow. Next one is cancelability. And so this allows clients to have an explicit mechanism to cancel operations. So this enables cleaner termination of long-running tasks, allows you to shut things down gracefully. And then finally, session management, which allows you to manage state across multiple connections. And so that means that whenever an MCP client disconnects and reconnects, the server can remember what was happening before. So if there's any variables, context, partial results, or conversation history that was shared, all of that can persist across the different connections. And so this is going to be really helpful, especially as developers start to build more and more sophisticated agent-to-agent communication patterns. And one of the big components of remote MCP is authentication and authorization. So when building a remote MCP server, you need a way to allow users to log in and prove who they are, that is authentication, and then a way for users to control what their AI agent will be able to access, so that is authorization. And there's a lot of open MCP servers that don't require either of these. For example, we have an MCP server that allows you to query Cloudflare's documentation. But for any service that requires a login or their sensitive data, it's really important to have these building blocks. There's a ton of examples on the Cloudflare AI repo, which I'll share later, that has examples of remote MCP servers that integrate with different auth providers. And actually, one of our favorite ones is Auth0. And that's because it implements a lot of the security controls that you want to have in place in order to enable this level of secure communication. And so we talked about these three building blocks, but almost every MCP server is going to have these three. So what is going to make your MCP server different than the rest of the other ones? So we have a little secret sauce that we developed at Cloudflare. But in order for us to dive into that, let's take a step back and think about what makes MCP so magical. So I'll give you all a personal story. Just a few months ago, I started using Claude to help me do some vibe coding for some personal projects. And I was very much in that pre-MCP world where it was giving me the code, I was copying and pasting. But then MCP came out and we built a Cloudflare MCP server that allows you to get that code directly deployed on our network. And so now I was very much doing the role of a product manager, directing Claude, this is what I want to build, this is how I want to build it. And of course, it would follow my instructions and help me build these projects. And what felt really magical and what gave me the light bulb moment about MCP is that before, using a service meant that you had to go through a dashboard or through an API endpoint. And what's frustrating about it is that it's one experience that's built for everyone and it's never tailored towards you. So, you may be using a service one way, but there's 100 other people that are using it in a different way. And, you all go through the same entry point. But with MCP, it's a lot more different because it feels like every interaction is catered towards you. And this is because you have, your conversation history, your requests, and it stores that context and it uses it when it makes each one of these tool calls so that they can be better and better. And now when I use a Cloudflare MCP server, it feels like I'm using a version of Cloudflare that's built specifically for me. And what makes this kind of interaction possible is that my client, so maybe Claude in this case, it keeps track of the conversation that we're having. And with every response that it returns, it references this previous context. And so as I tell it, this is what I want to build, this is how I like to build it, it stores that and I can see it in the results that it produces. But then, one day you go to your chat and the chat history gets a little too long, happens, and you start a new session. And that's where you feel like you go back to square one, where all of a sudden it loses that conversation history, it loses that context. And once again, you have to go through, the whole process of giving it information around what you're building, how you like to build it, how you like to interact with it. So, of course, easy to want to get upset at Claude. How could you forget all of our conversation history together? But actually, Claude is not the one to be upset at. And this is because, let's say tomorrow I decide that I want to use a different agent. Let's say I want to use VS Code or Cursor or maybe something that I built myself. Whenever I interact with the Cloudflare MCP server, I'm logged into my account. I will actually expect that no matter which client, which entry point I'm using, I would hope that it holds on to that context so that no matter where I use it from, the interactions get better and better and continue to be tailored towards me. And so what that means is what I'm actually looking for here is for the MCP server that I'm using to be able to hold some memory of the previous conversations and interactions so that every time I use it, I get a better response. So we only have 5 minutes left. So I'm actually going to go through the rest of the slides. And if we have time, I'll go back to the demo. But what I want to show you all is I built this MCP server that is able to hold memory on the MCP server itself, and it is based on the actual user. And this is an MCP server that keeps track of my book preferences, what books I've read. And the nice thing is that I can ask it to give me a recommendation. And every time that I ask it to use the recommendation tool, it will reference this context that I gave it through different interfaces to give me a response. And so, I can ask it for a recommendation. It gives me a book. I go to my library, I pick it up, maybe it takes me a month to read it. A month later, I can come back from a completely different client, completely different session, and I can tell it that I read this book, and it will hold on to that memory as well as other things that I've read. And when it gives me that recommendation, it's going to reference that knowledge to give me something that I haven't read and something that's a bit more tailored. And so the reason why it was easy to build this on Cloudflare is that when you build your MCP servers on Cloudflare, that MCP server actually holds memory by default. And this is because it is built on something called durable objects. So you can think of durable objects as personalized agents that can get spun up for every user that logs in. And this durable object can run compute, and it has storage built into it. And so that's important because it means that every user can have their own little mini database with their context, the tool call history that the MCP server can reference. And storing user data is not a new concept. We did not invent this. But today, if you think about if you have an API endpoint and you're interacting with it, that API endpoint may need to make a call to a separate database to go and fetch this data or to go and store the preference. But the difference is that with Cloudflare, your agent actually ends up being your backend. And the state just exists whenever you need it. It scales automatically. It runs closer to the users. And this is because every user gets their own isolated compute and storage component that's automatically built into the MCP server. You don't have to go and build a different database for storing all of this or worry about the latency. And you may be wondering why I'm saying agent when we're talking about MCP servers, but the main thing to take away here is that we make it easy for you to make your agent the MCP server so that it can hold on to this knowledge. And for anybody that's a developer, I know you want to see the code, but essentially the way it works is you have this MCP agent class that comes from the agents SDK, and it can take in props, which is information about the user that you get from the OAuth flow. And what it does is it will start a new durable object instance for every user. So it always starts with an empty list that's blank when you first connect. And then all you have to do to store preferences in it is call this.setState. And so what that's going to do is take its input and automatically add it to the durable object that it invisibly spun up for the user. And so then if I make a call to the get recommendations tool, when I make a call to the get recommendations tool, it's going to get the user information from the login flow, and it's going to look up my preferences by just making a call to this.state.favorite genres. It's going to load that list. And what I can actually do is build a personalized prompt that says, recommend, this number of books for somebody that likes these genres and recently read this. And this is how that prompt can continue to be modified to give me a better response every time. So last thing I want to leave you all with is we've been building a ton of MCP servers on the Cloudflare side. We've been helping customers build these. And some of the things that we've learned is that your tool design is very important. When MCP first came about, a lot of people were building one-to-one wrappers around API endpoints. But what we've actually found is that fewer well-designed tools are much better than a ton of granular ones. It definitely helps the client process the response better. Also recommend making sure that you have scoped permissions to reduce the risk of overprivileging access and just making it easier to manage and audit what the server can do. Also, the more detailed your tool descriptions are, the better your agent can understand what it should do. And then finally, definitely recommend using evaluation tests to measure your agent's ability to call these tools, especially if you want to test it with different models and see how it performs. So I'm going to leave you all with this. Go build your MCP servers. We have a ton of examples that you can get started with in one click. The AI playground that I actually showed you all, we actually open sourced that today. So you can also one-click deploy that and build your own MCP client with chat and LLM models integrated into it. So yeah, and if you build anything, please tag the Cloudflare Twitter account. We would love to see what you build.